In this video, we begin our work with categorical propositions. We're going to use categorical propositions for the entirety of the third test. So we're going to look at categorical propositions when it comes to proofs, when it comes to Venn diagrams, and when it comes to mood and figure. So here, we're going to restrict ourselves to looking at just the components of categorical propositions first. So what is a categorical proposition? It's a proposition. Remember, a proposition is a statement. It's a sentence that has a truth value that relates now to different classes. In chapter 1, we talked about a sentence or a statement that would relate one class. Now we're talking about two different classes. So if I said American Idol contestants hope for recognition, what I'm really saying is that there is a category called American Idol contestants who are included in the class of people who hope for recognition. So it's relating to different classes. There are 4 standard form versions of a categorical proposition. This is what we will use. If you were to take a higher level logic course, you would learn how to translate some English language statements that were not in standard form into standard form. But at the moment, we're just going to look for categorical propositions that are in standard form, if and only if they are exactly like one of these 4. All S or P, no S or P, some S or P, and some S are not P. The S and the P stand for subject term and predicate term. And they are not the subject and predicate of the sentence in the English grammar sense, but are the subject and predicate terms in the sense of where they are located in the standard form categorical proposition. So what's between one of these, the all, no, or some, and the are or are not is going to be called the subject term just because of its location. And what's after the are or are not is going to be the predicate term because of its location. Whatever term is there will be the predicate term at that moment. So let's diagram an example of this just so that we can see. So the words all, no, and some in standard form categorical propositions are called quantifiers. Why? Because they specify how much of the subject class, S, is included in or excluded from the predicate class. So this all is the quantifier. It tells us how much. The subject term, because we're looking at all are, is this entire thing, members of the American Medical Association. And the predicate term is people holding degrees from recognized academic institutions. This, the are or are not, is called the copula because it couples everything together. Each one of these standard form categorical propositions has a letter associated with it that is shorthand for it. So all S or P, we call it an A statement. No S or P, we call an E statement. Some S or P we call an I statement, and some S or not P we call an O statement. So in the example that we looked at, this would be an A statement. And if we translated this into standard form categorical propositions, what we would get is all, and then you can use whatever term you like or whatever letter you like. It's like a variable in mathematics. I would suggest, however, that best practice is not to use the actual letters S and P. get into the practice of using a letter that will remind you of what the actual term is that it's referring to. So I'm going to put M for members of the American Medical Association, and I'm going to put D for people holding degrees from recognized academic institutions, just to avoid using S and P. So here, all M, R, D would be the standard form categorical proposition that comes from this categorical proposition that wasn't in standard form entirely. Also, these two and these two are related to one another in a different way. They're related to one another because these are called universal statements. Why? Because it talks about all of something or none of something. And these are called particular statements because they talk about something particular. Some S are not P, some S are P. That means at least one S is P, or in the class, in the P class. And this means at least one S is not a member of P. So if we're thinking about it that way, all S or P really means that every member of the S class is a member of the P class. All members of S are members of P. If we look at E, no S are P, meaning no members of S are members of the P class. Some S or P would mean at least one member of the S class is a member of the P class. And some S or not P means at least one member of the S class is not a member of the P class. If we look at this in graphic representations, because these are not Venn diagrams, these are just drawings, we would see that all S or P, the A statement would look like this. Every member of S is a member of P. If we looked at no SRP, the E statement, you would see that it would say no members of S are included in the P class. They're just simply separate from one another. If I looked at some SRP, what we call the I statement, we would use an asterisk just to designate at least one. And we would say in the P class, there's at least one S. We don't know how many more than that, but there's at least one. Then the O statement would assert that there is at least one S that is not included in the P circle. So these are the standard form categorical propositions. They are the A, E, I, and O statements. They could be universal or particular. And we can take a look at an English language statement and say, here's the all are, use letters to represent the terms, the subject and the predicate term, and create a standard form categorical proposition of our own from an English language argument. Next, we'll talk about how the traditional square of opposition can be used to relate these standard form categorical propositions to one another.